In this lecture, we're going to look at how the HART protocol represents logic 1 and logic 0 physically on the bus itself, on the twisted pair wires. So let me explain exactly what I mean. Most serial buses use voltage to represent logic 1 and 0. For instance, RS-232, 422, 485, they all use voltages. Even Ethernet on twisted pair, it uses voltages to represent logics 1 and 0. HART, however, is different. It uses signal frequency. In order not to disturb the milliamp current on the 4 to 20 milliamp loop, the HART signal is superimposed as a frequency. The milliamp signal is a direct current and the HART signal is a very low voltage alternating current, and both coexist on the twisted pair wires without interfering with one another. Now you'll be very familiar with alternating current of 60 Hz and 50 Hz. That's your household supply. It depends on the country you live in. Now HART uses one frequency to represent a logic 1 and another to represent a logic 0. Specifically, it uses 1200 Hz to represent logic 1 and 2200 Hz to represent logic 0. So when data is being transmitted, the frequency of the HART signal constantly shifts between 1200 Hz and 2200 Hz. This method is actually called frequency shift keying, or FSK. This was actually first used for telephone systems to implement call ID, believe it or not. Let's look at a visual representation of these signals. So have a look at this graph. You're seeing it's time on the x-axis, 4 to 20 milliamps on the y-axis, and it says simultaneous analog and digital communication. So this straight line here represents our 4 to 20 milliamp signal, and you can see with time it increases. Most likely the process value would have increased, so the milliamp signal increased. But riding along with it here and increasing along with it is this signal, but the amplitude of this signal doesn't matter at all. It's the frequency of the signal. So you're seeing this is our 2200 Hz here, it's a 0, and this wider wavelength here means a lower frequency of 1200 Hz, which represents a logic 1. So 10010. So you notice that the frequency constantly shifts as the signal propagates along to represent ones and zeros. So that's why it's called frequency shift keying. Now the HART signal does have a small voltage associated with it. So why is it that it doesn't disturb the 4 to 20 milliamp, the voltage, and consequently the current? Well, it's because it's a sine wave, or almost perfect sine wave. And it's because it's alternating so fast. Here's a positive amplitude and then a complementary negative amplitude. So they cancel out one another constantly as they go. So it's almost like a perfect sine wave, cancelling out the positive amplitude, cancelling out the negative amplitude. So we say that the average value of the FSK signal is always 0. Hence the 4 to 20 milliamp analog signal is not affected. So it's pretty innovative when you think about it. All right, let's move on now. So now the FSK implementation used in HART is not very fast at all. The HART protocol uses only one serial speed, and that's 1200 bits per second, which is really slow. Now, specifically being a serial protocol, its serial communication settings are fixed to this: 1200 bits per second, 1 start bit, 8 data bits, odd parity, 1 stop bit. Now, unlike with, for instance, Modbus, you can't change this. This is set as that. So it's a slow protocol. So there's no choice. This is one of the reasons that HART is mainly used for setup, diagnostics, maintenance, and troubleshooting. It was not designed for high-speed data acquisition, as you can clearly see. For high-speed data acquisition, that's where things like Modbus, Profibus, Profinet, CAN bus, etc., that's where those protocols come in. So that's a bit of a limitation. Now, one last point that I would like to make as we are on the subject of FSK. If you have dealt with common industrial network protocols, you will know that several of them can use different types of physical media. For instance, Modbus can use RS-232, 422, 485 Ethernet. This is not the case with HART. You will never hear HART being used over Ethernet or RS-485 or anything of this sort. HART is standardized to work over twisted pair wires where there's usually a 4 to 20 milliamp signal present. And that's fixed. That's where HART is used. That's the physical media. There's nothing else. All right, so just keep that in mind.